Today I'll be showing you how to make a ragdoll module and how to utilize it in your game. And this module is pretty big, so let's get started. I have a template down in the description for you guys to use, and in case you don't want to press the link, you can copy the asset idea and paste it in the creator dashboard to get this too. And I highly recommend you use the template for this video. There's a lot of stuff. Alright, first things first, we must rig our humanoids to be able to ragdoll like this. So first, we must insert a ball socket constraint into each part of our humanoid. To do this, we must create an attachment, 2 attachments for each ball socket constraint. If I only select my right leg, and once I get off the trampoline, this ball socket has 2 attachments, one on its right leg and one on the torso, in order to create a joint. Normally, you have to create one attachment in the right leg, like in a dummy, and then go into its transform and like adjust it until it creates lines up with the torso. And then you create another attachment for the torso in order to connect the right leg, and then mess with these settings until it lines up with the leg. However, this task is pretty tedious and a bunch of people have already done it. So you can just copy and paste the script I will have in the description to fully rig up your model. Right, when you open the script up, this entire function has been done for you, and so I'll just break it down real quickly. So first, it creates a tag and adds it to a character. It also creates this int value and adds the ragdoll timer int value to your character, which will be used for how long you get ragdolled. And this is to indicate that the humanoid can be ragdolled by something. In case like a humanoid that hasn't been rigged yet touches a ragdollable hitbox, it won't throw an error, and instead you can do whatever you want with it. Here, a table, it has all the positions for each attachment, the offsets. So here it makes the first set of attachments, and then it creates the second set of attachments for each one. And after this, we create all the ball socket constraints and connect them to each attachment. And the first set of attachments are named ball attach, and the second set of attachments have specific names, which I manually typed out here. And then finally, this part is configuring the ball socket so you don't bend in completely weird ways. Now, for additional stuff to make this work is, first you want to add a local script here and call it knockback, whatever. And this is to apply velocity to your character. You cannot add velocity on server side to player humanoids. It just doesn't work. Or even if it does work, it's just a lot more complicated to make it work. So you should add this and then copy and paste all of this in there. I'll probably have this in the description too. And then to connect them, make a server event inside of, or not server, a remote event in your replicated storage. Call it knockback, you can or whatever you want. And in the template, I should have the function already written out here. Uncomment this out. And this function is solely used to apply knockback to the player models. So if it's like an AI dummy, then you don't need to use this function. You only put it for players. That's why I've set it so it only accepts player values here. Alright, now it's time for the main ragdoll function. We accept the character model, which is a model, and then the velocity, which is our knockback. First, we set the platform stand to true, remove the auto rotate, and set the change state to ragdoll. It doesn't look like it does anything at first, since these two basically ragdoll the humanoid, but this actually helps the script apply knockback a lot better. It's some behind the scenes stuff. So now, and then this is where we get started here. Usually, normally the ball socket constraints are disabled, because motor 6D is what's enabled connecting our body together and what allows us to do our animations. So we disable all the motor 6Ds in the character and then enable all the ball socket constraints in the character in order to allow them to flop around like crazy. After that, we determine if the character model has a player. If it doesn't, then we run our function to apply the velocity local side. If not, we apply the velocity server side. Now, to unragdoll your character, we just undo everything we did in our ragdoll function. Reset the platform stand, turn back on auto rotate, change the state to landed. This will default back to whatever state it should be on. Re-enable your motor 6Ds to allow your limbs to move normally, and then disable the ball socket constraints. Now, this function is for simplicity stuff. This function ragdolls the character for a set amount of time and then unragdolls them. So we ragdolls them here, place that function, then sets the ragdoll timer using this function. And the ragdoll timer is every 1/10 of a second. That's why I multiplied the duration by 10. So if you put in 2 seconds, it will add in 20 into the ragdoll timer. And that's because I reduced the number by 1 every 0.1 seconds, which is 10 times as fast as a second. So, and then there's the task.spawn here too. What this does is I'll show an image to explain it, but basically it allows everything inside here, even if we're waiting for something here, it will still run the rest of the script, so it won't stall the script. Now, After it will count down, and once it hits 0, it will end this loop and then run this line here, which will unragdoll the character. Alright, by now you should be able to achieve a basic ragdoll, and in order to test that, just get a part like this one right here and run the functions using a basic touch script right here. This just touch script, find the character model, and then use your module that you've got made and run it through. Add some upward velocity and some duration and see what happens. Now it's time for the advanced section of the video, the impact crater. When you hit the floor really hard and it creates a ring of rocks. Let me explain how to track impact. So first we use run servers.presimulation, and basically what the delta means is, some people might not know, is presimulation fires every time physics is about to load. So it fires once here. Oh wait, that's not a draw. It fires once here, and then it takes a certain amount of time for the next one to fire. And that delay between each physics pre-simulation fire, when this one fires, it will tell you how much time it took for that one to fire from the last one. And we use that time because with velocity, our humanoid will be flying through the air, and we can multiply the humanoid's velocity with the delta in order to see how much the humanoid will move according to its velocity in how much time it takes in delta, because delta is a small amount of time and will travel a small amount of that velocity will travel a small amount of distance, which gives us precision. And we use that and we plug it in a raycast, which is an arrow that shoots out or a line and sees if it hits something, and we use that to determine our raycasting, and if the raycast hits something, then it will detect an impact. Alright, to put this into script, we get this pre-simulation event. Then we make the raycast params, a raycast result. And for the raycast result, this is what we got to put in. The first part is we got to put in a C frame for a block cast. So we put in last position. And the reason why it's here is because to prevent errors from occurring, because last position doesn't exist until we declare it for the first time. So on the first simulation, we'll go blah, 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 last position, and we didn't declare last position until here, so this will be nil. And then after the first one, then we'll finally start firing the raycast. I mean, you could make it so it does fire on the first raycast, but I did it this way because it makes it more accurate. Even if you 0 frame get punched into a wall, the explosion won't even be that cool anyway. So we do that, and then after that, if raycast result is true, and this part, which I'll explain in the next clip, is true, then we move on. Let's do a quick vector 3 lesson real quick. So we have this vector right here. This is the velocity of a theoretical part that hits the wall and bounces off with a reflected velocity of that same vector, which is -2, 3. So in this scenario, we can just easily flip the vector across this line. But in a scenario like this, we can't simply do that. We have to do some more complicated stuff. So this equation here just does it automatically. It's called the vector reflection formula, and it works for every reflecting scenario that you need. So, but if you don't want to hear the explanation of how it works, you can skip ahead. Alright, vector reflection. So dot product, we get xa, xb at multiplying together plus blah blah blah. So for this question, we get 0 times square root of 0.5, which is 0, a times square root of 0.5, which is 5.656, 0 times 0 is 0. Then you add up each of these together, then you get 5.656 since only the center component is different. Then you get our dot product multiplied by the wall normal, which is the negative square root 0.5 and square root 0.5 and 0, which will give you negative 3.99, 3.990, which is really close to negative 440. We'll go with that. We get our original vector 080 subtracted by this vector multiplied by 2, which will get us 800, or negative 800. I messed up. It should be negative right here. Negative 800, which looks perfect here because this up arrow is 080, and then it's going backwards by negative 800. This is how vector reflection works. Pause the video if you need to study the diagram. I wrote in the equation here because this check is, I took this portion, which is really just, this is the original vector, and it's reflected when we subtract it with this portion. So I want to check if the impact, the reflection amount is strong enough so that, like, I don't want them to make a ring of rocks if they just like tap the ground. So I added this check right here, which takes this portion right here and checks if the dot product is above 15 to see if they hit the ground hard enough for you to bounce off. Now I have this to print. This is to check if it works. Then I have this additional bounce, which is just increasing the power of my bounce. The reason I did this is because of how Roblox physics works. If you ever try to move a player character, it heavily dampens or like weakens the velocity. So I added all these things to increase the velocity power. Otherwise, you don't actually need this. This is just for extra power in a very more specific way. The easiest way to add power, if we're not using that bit, is I remove this, is to just multiply the reflected vector. So this is where I actually put in the formula, which is v minus 2 times dot product times n. Now, the dot product, just so this here, this will do the dot product for you. They have a function for that. And once I get my reflective vector, I send that reflected vector, which is going to be our new velocity, into our player knockback function. And if it's not a player function or player model, then we just do it on the server side. And now the final bit is the cube ring. I did a visual animation to show you how the cube detection works. So it shoots a C frame, and then it rotates and spins in a circle and shoots raycast down to check if it's valid for a cube spot. Now for the script itself, we get the impact zone, which is the position. The normal, since the normal is a perpendicular line, it shoots straight out of the impact zone, which helps a lot. And then we have our radius. Our radius, you can set it to be a preset amount. Just put like 10 probably, but for me, I set it so this line right here will determine how big the rock circle will be, and it will determine how big the size of the rocks will be using this equation. You can just set it to like 25 if you want to keep it simple, but this adds realism, and I thought this was necessary. Just copy this. I don't want to explain this part. This is just math. Now for the cube ring, it creates a start C frame by creating what I discussed before. The impact zone sets this C frame, which is our start C frame here, puts in the size, just a bunch of math. You can mess with it if you want. This is the test piece. I use this for testing purposes. You don't need to put that in. Then this is to determine what sound is played, depending on how big the radius is. You don't need to put that in. So this is the spinny part. So it will rotate 24, it will iterate 24 times and spin 15 degrees each side. So it will do this, spin 15, and then run this. This is the breeze. It will delete the cube after a while. The breeze is declared up here, game.Breeze. When you put it this add item cube, 5 seconds, it will destroy the cube in 5 seconds. Then after I do that, I get a ray position. This line right here is after it rotates it, it will move it out. So it rotates so it's facing outwards right now, or I forgot. Supposed to face outward. Then it will face like this way. Go forward. This is the ray position, and then this is the ray check where I actually make the ray cast. Then I just make the normal go back to the wall, since the normal is always flying out of the wall. Then rotate it like this way. Then it will shoot a ray cast this way, check if there's a wall. If the ray cast hits, then I make a cube at that location, and that's how I make the cube ring. You put this all together, and it should all work. This is probably the most complicated thing I did for this channel. That's weird. I don't remember putting a seat there. Yeah, that should be the end of this video. I was a little lazier with this one because I spent a lot of time trying to figure out how could I explain. Why did double impact? That shouldn't happen too much. So yeah, I spent a lot of time trying to figure out how to explain this. I hope this was helpful. This effect is really cool. It's also really complicated. So yeah, have fun with your Battlegrounds games. Might make a tutorial on that too, maybe. All right, goodbye.